ordinary differential equations. I will share this PDF with you through WhatsApp. You will get the details. So there is, you get ready with pen and paper. So sometimes you may have to do some calculations. So differential equations. So there are two types of differential equations: ordinary and partial differential equations. We know that. Ordinary differential equation is that in which you have one dependent variable and one independent variable. And in partial differential equation, you have more than one independent variable. So differential equation, why we need to study? For example, suppose there is in the question that the velocity of a particle is 60 meter per second. Mathematically, how will you represent that equation? Velocity of a particle is 60 meters per second. Mathematically, how will you write that equation? Anyone tell? Got the question? Anybody respond? How will you write it mathematically? Velocity of a particle is 60 meters per second.
So ds by dt equal to 60.
Yeah, ds dt equal to 60. So s means the position of that particle and t is time. Means if s is the position of that particle at time t, then from this question we can write that ds dt equal to 60. So question may be that what will be its position after 5 seconds. How will you find it? What is its position after 5 seconds? How will you solve?
Meter.
You don't have to give the exact answer. What you will do, that you tell me. The ds dt equal to 60. That is the equation you have got. Now I am asking what will be its position after 5 seconds. How will you find that?
We can integrate
both sides. We will integrate, yeah.
We will
By
integrate.
integrating, yeah, first you will integrate, then what you will get, s equal to
60t.
s equal to 60t plus some constant.
Yes, sir.
Okay. So you are getting s as a function of t together with some constant. So if we can determine value of the constant with the help of some initial condition, then we just replace t equal to 5. That will give you the position of that particle. So this type of problems we can solve. So there is the need of differential equations. In many experiments, such type of things we will come across, which can be modeled with the help of differential equations. So here there was only one independent variable, which is time. That's why it is called an ordinary differential equation. But in many cases, there may be more parameters in which a variable depends. In such cases, we have partial differential equation. So in this particular unit, we will learn about only first order ordinary differential equations and their techniques of solutions. The techniques of solutions are also needed to solve that type of problem. For the first slide, all these things are written. What is a differential equation? Then what is a partial differential equation? What is order of a differential equation, degree, etc. Linearity, non-linearity, all these things. Differential equation is an equation of one or more dependent variable with respect to one or more independent variable. For example, here one differential equation is given. dy equal to x square plus cos x dx what is the order of this differential equation? Order of a differential equation is the highest order derivative involved in a differential equation. So what is the highest order derivative in this differential equation?
Two.
One.
In this first equation, dy equal to x square plus cos x
One.
into dx.
One.
Sir, order one.
It is one because we can write it like dy dx equal to x square plus cos x. So only first order derivative. First order, it is linear also, and degree of a differential equation, degree is the degree
One, sir.
of the highest derivative. So highest derivative is 1, its degree is also 1. So it is first order, first degree. And linear differential equation, here it is written, a differential equation is linear if every dependent variable and every derivative occurs in the first degree only, and no product of dependent variable or derivatives occur. So here the dependent variable is y, and its derivative occurs in first degree. First degree means power 1. So that's why, and no product of the dependent variable or derivative occurs. So it's first order, first degree, and linear. Next, another differential equation is given. It is not very clear. I'm telling you, it is d4x dt4 plus d2x dt2 plus dx dt to the power 5 equal to e to the power t. Now, what is the order of this differential equation?
First order.
Order one degree.
Fourth order.
Second order.
Order is 1.
Order one degree.
Order. How order is 1? You see, what is order? Order
Order 4.
is the highest order derivative. The order of the highest order derivative is called order. So what is the highest order derivative?
4.
Is d4x dt4. So fourth derivative is the highest order. So it is not of order 1, it is of order 4. And degree?
One.
Degree is 1. Degree is 1. 4 or 5. Order is 4 and degree is 1.
It's one.
Order is degree is one.
Yeah, order is 4, degree is 1.
One.
Okay. Order degree both are connected with the highest order derivative. If here highest order derivative is 4 and its highest order is called this degree, highest order is 1 only. You see the definitions all are written here. So then, and this is linear or non-linear. This differential equation is linear or non-linear. Linear means the
Degree 1.
independent derivative. It's linear or non-linear. Here you see the definition of linear and non-linear differential equation.
Linear, sir, because degree one.
Linear because degree 1 of what? Degree 1 does not mean linear always. You see what is written.
Non-linear.
A differential equation is called linear if every dependent variable and every derivative involved occurs in first degree only. The independent variable here is x, and every derivative occurs in first degree. Is every derivative of first degree? This fourth order derivative is of first degree. Second order, that is of first degree.
This
But here is a first order derivative
non-linear.
which is of fifth degree. Hence it is non-linear. Understood? So
Yes.
degree of the differential equation may be 1, but still it may be non-linear. So then our main aim is to find solution of a differential equation. These things are necessary to know whether it is linear, non-linear, etc. Because which techniques we are going to apply will depend on its category, whether it's linear or non-linear. So that's why first you need to identify which is the dependent variable, which is independent, and whether it's linear or non-linear. So next, our aim is to find a solution of the differential equation. So any solution means any relation between the dependent and independent variable which satisfies the differential equation. That is called a solution. You know it. Now, types of solutions, several types of solutions are there. Suppose this is an nth order ordinary differential equation. Now, a solution of it consisting of n independent arbitrary constants is called a general solution. So usually, if you solve a second order differential equation, in its solution you will have two arbitrary constants. It will be called a general solution. Now, there are some other types of solutions also. When a solution is obtained from a general solution by giving particular values to one or more arbitrary constants, it is called a particular solution. So, for example, this y equal to c1 e to the power x plus c2 e to the power 2x. This is a solution of this differential equation. After solving it, we get this differential equation. This will be called a general solution because it is a second degree differential equation, and there you have C1 and C2, two arbitrary constants, hence it is a general solution. Now, this is also a solution of this differential equation, but here you see arbitrary constants are not there. In place of arbitrary constant, we have put C1 equal to 1, C2 equal to 1. So we have got this equation. So it is a particular solution. When you give particular values to the solutions, you have a particular solution. Here we have given the values C1 equal to 1, C2 equal to -2. So we have obtained this particular solution. So these are all particular solutions. Again, if we solve this differential equation, we get this general solution. Now, this is a general solution. Now, y equal to 0 is also a solution of this differential equation, because you can very easily see that y equal to 0 satisfies this differential equation. But you cannot obtain y equal to 0 by giving any particular value to this arbitrary constant c. So c is this y equal to 0. This solution cannot be obtained from this solution. Such type of, but still it is a solution. Such type of solutions are called singular solutions. Understood? So there are three types of solutions: general solution, then particular solution, and singular solution. Particular solution is easy to understand when you give particular values to the arbitrary constants, but singular solution cannot be obtained by providing particular values to the arbitrary constants. It is obtained in a different way. It is still a solution, but you cannot obtain it from the general solution. So whenever you have any question, you raise it. So now let us discuss some methods of solution. Solution of first order and first degree differential equations by exact method. By exact method. So see, if suppose we want to solve this differential equation. here we have a differential equation. X square minus 4xy minus 2y square dx plus y square minus 4xy minus 2x square dy equal to 0. This is a differential equation. We want to solve it. Possibly, I don't know whether you know how to solve this type of equation. In higher secondary, you might have studied certain techniques of solving differential equations. With those, you may or may not be able to solve this. So first, we will try to learn that exact method. You can very easily solve this differential equation. So for this, we will apply exact method of solution of differential equations. So first, we need to know what is an exact differential equation. You see, if m and n are functions of x and y, the equation m dx plus n dy, it is of this form. Here you have an expression, this is m, a function of x and y, m dx plus n dy is of this form. The equation m dx plus n dy equal to 0 is called exact when there exists a function f of xy such that total derivative of f equal to m dx plus n dy. For example, if we have this differential equation y square dx plus 2x dy equal to 0. Now this expression on the left hand side can be written as d of x y square equal to 0. Can you understand this? Somebody tell. So these are the demerits of online classes. Directly we cannot get your feedback whether you are
Sir, can you please
understanding or
repeat
not.
the last?
Sir, the slide is not clear.
Not clear.
Yes, sir.
Now,
Sir, a bit more zoom.
So same for all, sir.
A bit more zoom, sir.
Zoom.
Yes, sir.
it's not zooming much.
Sir, control scroll, sir.
Okay.
Yes, sir.
Yes, sir.
How is it visible?
Better.
Yes, sir.
Yeah. So what I'm telling, so we have this type of a differential equation. M dx plus n dy equal to 0. So here we have this m dx plus n dy equal to 0. We are writing it as d of xy square equal to 0. Do you understand this step?
Yes, sir.
How that is coming? It is coming from this. This is when you have d of xy square, it means the derivative of the function f with respect to x into dx. So here this is partial derivative del f del x. By treating y as constant, we are differentiating this. So if we differentiate this by keeping y as constant, what we will have? Only y square, isn't it? So y square and derivative of x will be 1, y square into 1 dx. Next, it will be derivative del f del y, means derivative with respect to y, and we treat x as constant. So x constant, derivative of y square with respect to y will give you 2y. So twice xy into dy. Okay.
Yes, sir.
Yes, sir.
Getting it or not?
Yes, sir.
Great.
Sir.
Yeah, it is like that product rule of derivative. Derivative of uv means what? U into derivative of v plus v into derivative of u. Like that. Only difference is that here you have two independent variables. That's why partial derivative of f then dx plus partial derivative of f into dy. So this expression on the left hand side may be written as d of xy square equal to 0. Now by integrating this, if you integrate this, you get simply xy square equal to some arbitrary constant. Right? That's how we can solve. This is by inspection only. By inspection, we could see that this expression can be written like this. So now, always inspection may not be possible. That was a very simple case. That's why inspection was possible. But always you may not be able to determine by inspection whether it is exact or not. So not to worry, there is a method, established method for this by which we can determine whether a given first order partial or ordinary differential equation is exact or not. The method is this: necessary and sufficient condition for NOD to be exact. So the necessary and sufficient condition is if del m del y equal to del n del x, then it is exact. Okay. So here we have the working rule for solving an OD if it is exact. So suppose we want to solve this differential equation, it is given. In the exam, these things are not given, solve by exact method or whatever method. You need to determine which technique of solution you can apply. So first thing we check is whether it is exact or not. So first we will see whether it is first order or not. So this exactness is applicable for first order differential equations only. So this we can see very easily that it is first order ordinary differential equations of the form mdx plus ndy. So first thing we will check whether it is exact or not. So the condition is this: we will check del m del y equal to del n del x or not. So check first with your pen and paper whether it is exact or not. This is your m dx plus n dy. So check if it is exact or not and tell me. Check this and tell me. This is your m. I have written this m dx plus n dy. This is your n and this is your m. Check if this condition is satisfied or not.
Satisfied, sir.
So what do you get? Yeah, del m del y equal to what you get? Tell me the expression.
Minus 4
Del f
minus
minus 4
minus 2 minus 4
4x minus 4y.
4.
Satisfied, sir.
Yeah, tell me the expression.
Minus
Del m
4x minus 4y.
minus 4x minus 4y, and del n del y is also minus 4x minus 4y. We are performing partial derivatives. So del m del y means we are differentiating this expression with respect to x. What is this sound? Keeping x constant. Here we keep y constant and we differentiate with respect to x. So we get that this condition is satisfied, minus 4x minus 4y. So it is an exact differential equation. So if it is exact, we can apply this working rule to find its solution. The working rule is, let us see what is the working rule. First step is integrate m with respect to x, treating y as constant. So after you have checked that it is exact, directly we can write, therefore the solution is, we integrate m, we have written m with respect to x by treating y as constant. So that is what is written in the first step. Integrate m, treating y as constant. Next step, integrate with respect to y only those terms of n which do not contain x. So n is this. Integrate with respect to y. So dy, only those terms of n which do not contain x. So this term contains x. This will not be integrated. This term also contains x. This will be neglected. Only this term does not contain x. So only this will be integrated with respect to y square dy equal to an arbitrary constant. Here I have written in short what you need to do. Integrate m with respect to x, treating y as constant, plus integrate the terms in n not containing x with respect to y, equate the expression to an arbitrary constant. That will be your solution. So after doing the calculations, we arrive at this solution. Understood the technique? If you have any doubts, you can ask.
No, sir.
No, which step? Tell me where you have doubt. Tell me if you have any doubts, or did you understand? Then read the working rule.
Understood, sir.
If anybody did not understand, then also tell. So I assume you have understood. Simple, it's written here. Integrate m with respect to x by keeping y constant, then integrate terms in n not containing x.
Yes, sir.
Y and
Understood, sir.
an arbitrary constant, and then we arrive at a solution. So this is called the exact method of solving first order ordinary differential equations. So if it is of this type, m dx plus n dy, first you will check whether it is exact or not. Check exactness. This is the necessary and sufficient condition. So first we will check that. In this case, this condition is satisfied. Therefore, it is exact. Therefore, the solution can be written using this formula. Okay, here is another question regarding exactness. The question is, find the value of lambda such that y6 e to the power y plus 3y square dy dx plus dx square plus lambda e to the power y equal to 0 is exact. For that, solve the equation. find the value of the constant lambda such that this equation is exact. Solution is also written, so I cannot. So here the question asks you to find the arbitrary constant, the value of the arbitrary constant lambda so that this differential equation is exact. Okay. So what we are doing, it is of this form m dx plus n dy equal to 0. So we will check the condition for exactness. Condition of exactness is this, del m del y equal to del n del x. So we see that del m del y means if we are differentiating this with respect to y, you are getting, this term becomes 0, lambda into e to the power y. And del n del x, you get 2 into e to the power y, this becomes 0. So from this equation, we have the value of lambda equal to 2. The value of lambda for which this equation is exact is 2. After that, the question also asks you to solve it. So we have already checked that for lambda equal to 2, it is exact. So lambda is replaced by 2 here, and then the solution is this, like earlier. We integrate m with respect to x by treating y constant. Now we integrate terms in n which do not contain x. Terms which do not contain x is only this. Not containing lambda equal to 2. Terms in n. Here it is not 3y square, but what will it be tell? Here we are integrating m with respect to x. So m is 3x square plus 2 e to the power y dx. Here what you need to integrate terms in n not containing x. I have written here 3y square. It is not correct. What it should be? Tell.
Lambda e to the power y.
Lambda e to the power.
Lambda e to the power y, and lambda we have already got 2. So it will be 2 e to the power y that you will integrate. So not 3y square, you will integrate 2 e to the power y. And after that you will have the solution. It is not y cube. 2 e to the power y, if you integrate, you will again get 2 e to the power y only. Okay, so here you will have 2 e to the power y equal to c. So understood the exact method? Is
Yes,
this
sir.
only first. First you check whether the differential equation is exact or not by this condition. If it is exact, the solution can be obtained like this. Here is an error. I have told you, so rectify that error.
What error?
Hmm?
So what is the error?
The error is we should integrate terms in n not containing x. So here this is our n. So which is the term which does not contain x?
N is
N is this expression. N is this expression.
You have written 2x e to the power y plus 3y square.
N is 2x into power.
True?
So you written n is 2x e to the power y plus 3y square.
Oh,
Yes.
yeah. So, oh yes.
Yes.
MD. Oh yes. No, it's correct only. Yeah. Here you see, I thought this is dx, so it should be yes. It's correct only. You have to see the question properly. Here you see dy is multiplied with this, so this will be our n. This will be our n, and our M will be this. M is that expression which is multiplied with x, so there may not be any error. I was mistaken. This is only our M because the M is the term which is multiplied with dx. So dx, in the dx we have this term. Okay, understood? Dx equal to 3x square plus lambda a to the power y plus n. So first we have checked it is exact. So our M is this. M is this. Let me say M is constant. Now n, our n is this. And the terms in n not containing x. Terms in n not containing x is dy square only. Yeah, so this is correct only, no error. Understood what I earlier said? I was thinking this is x.
Yes, sir.
Okay, so no error actually. It's correct only. So this is our n. So from n we need to take those terms which do not contain x. So only this is the term 3y square which does not contain x. So after integrating we get y cube only. So it's correct. No problem. All right.
Yes, sir.
Next we have another method. So how is this online class? Are you understanding?
Yes, sir.
Yes, sir. Yes, sir.
Is this online class better or physical class? Which is better?
Physical.
Physical.
Absolutely. No replacement of physical classes. Since we are compelled now, we are taking online. So now there is another solution. Exact method we have discussed. There are some other methods also. So the next method is solution of first order and first degree ordinary differential equation by integrating factors. I will provide you problem sets for this also as usual. We'll practice more problem and suggest a book also. Let me tell you the book. The book is Ordinary and Partial Differential Equations by M.D. Raisinghania, where you can get all the details. You can follow any other book also, but in that book you will get all the details. So that I recommend you if you want to study Ordinary and Partial Differential Equations by M.D. Raisinghania. In that book you will find all details of this unit. So next what happens if the differential equation is not exact. So very often you will see the given differential equation is not exact. Then we have to go for some other methods. So if an ordinary differential equation of the form mdx plus ndy equal to 0 is not exact, it can always be made exact by multiplying by some functions of x and y. Such a multiplier is called an integrating factor. Okay, so when you see that directly a given differential equation is not exact, then also you need not worry. By a suitable function, by multiplying that given equation by a suitable function or a multiplier, we can convert it into an exact differential equation and then we can solve it like earlier. So how to do that? So in this regard, we have this result. An ordinary differential equation mdx plus ndy equal to 0 possesses an infinite number of integrating factors. So many integrating factors are there. So different students may obtain different integrating factors and apply them to solve the equation. So one note is that there is no general method for finding integrating factor. Below we discuss some rules. Some rules is, first rule is by inspection. So these following formulas will be useful. If you see this type of an expression, you can directly replace it by d y by x. Is that division rule of derivatives. Then some other formulas are there, like this very common formula dxy equal to x dy plus y dx. These are known to you. All of them can be obtained or proved by using either product rule of derivatives or this division rule of derivatives. You try and check the proofs of all these formulas at home. But whenever they occur in an expression, we can directly use their equivalent forms. Treat them as formulas. We discuss one or two problems of this type. So we consider this differential equation y dx plus x minus x dy plus 1 plus x square dx plus x square sin y dy equal to 0. We have to solve this. So you can see it is directly not in this form md. Previously we were discussing mdx plus mdy type of differential equation. Now there are several terms. We can also put it in by taking dx common, dy common. We can put it in this form, but still it may not be exact. We can apply other methods. This one actually we can solve by inspection method. Here you see what we have done. We have divided. So there is no general method how to solve this type of equations. You can apply your own logic to solve it. So here we have divided by x square the entire equation. So we have got this expression divided by x square plus 1 plus x square divided by x square, and here x square got cancelled out. We have sin y dy. Now you can see this one is directly integrable because only x is present. This one is also directly integrable because only y is present and we are integrating with respect to y. So this two does not pose any problem to us. Only this one. X and y both are mixed up. But you can see we can convert it into an exact form by using this formula. So this formula can be applied here. If we take this minus common, it becomes x dy minus y dx divided by x square. So its equivalent form is d of y by x. By taking minus common here, we have got this minus d of y by x plus this plus this. So now we have, next step, we have integrated all of them. Integration of this is simply y by x minus y by x. Integrating this, we have got plus x minus 1 by x after simplification, and integration of this expression is minus cos y equal to arbitrary constant, and that gives us the solution. Okay. Next, there is another problem. It's mdx plus ndy form. So whenever an equation is given to you, first you will check if it is exact or not. Simply this will not be exact. If it is exact, then you solve by previous method. If it is not exact, go to the next method. Here what we have done, we have simplified them. We have put them in a convenient form, x dx plus y dy plus this. Now we have applied this formula, tan inverse x by y. It is similar to this. So here you have x square plus y square and y dx minus x dy. So we have applied this formula matching with this. Here see we have applied this formula, and here x dx y dy, this can be integrated directly. No problem, and we have got this result. Similarly, there are other rules also. We will discuss one by one. I think this much should be enough for today, or what?
Yes, sir.
Yes, sir.
Yes, sir.
Tomorrow we have another class. So today I will share you this PDF. You can read at home the next things, and tomorrow we will discuss further.
Okay.
Together with syllabus, I will share with you. So you study. Yes. What did you say? Repeat. I did not understand. Okay, so today it's enough for today. Tomorrow we will discuss again. I will share this PDF together with the syllabus. You read it and get an idea beforehand.
सर इस बुक का नाम क्या था?
Book का नाम also I will share you a screenshot of that front page of the book in WhatsApp group.